Hello, this is the questions and answers on acids and bases. I hope that you have tried them and were able to do them. An aqueous solution of the organic compound methylamine has a pH greater than 7. So the first thing you ask yourself, greater than 7 means acid or base? Greater than 7 means it's a base. So which statement about the methylamine is correct? It neutralizes a solution of sodium hydroxide. Sodium hydroxide is a base, so a base does not react with a base, so A is wrong. It reacts with copper carbonate to give carbon dioxide. What reacts with carbonate to give carbon dioxide? That should be an acid, and we don't have an acid. It reacts with hydrochloric acid to form a salt. Yes, a base will react with an acid to form a salt. The last one says it turns blue litmus red. No, it's a base, so it should turn the red to blue. Okay. Hydrochloric acid is used to clean a metal surface by removing the oxide layer on the metal. Remember that we said an acid, if it reacts with something, then that something must be a base. This is because hydrochloric acid has, acid has high pH or low pH. Remember we said hydrochloric acid is a strong acid, so its pH would be 1 or 2 or 3. So it has a low pH. So my answer is either C or D. Now, the metal oxide that reacts with the acid has to be a base. So my answer is D. Right? Element X is at the left-hand side of the periodic table. Which line in the table shows the correct type and property of the oxide of X? So if X is on the left-hand side of the periodic table, that means it's a metal or a non-metal? That means it's a metal. And metals, the oxides of metals are usually basic, so your answer should be B. Okay, the pH of some aqueous sodium hydroxide is measured. The solution is then distilled as shown. So he's distilling a solution of sodium hydroxide. Now, what do you think would be the pH of the sodium hydroxide solution? Something like 12, 13, 14? Okay. Now he's distilling it and it's giving a distillate. What is the distillate? The distillate that comes out would be pure water, right? What's the pH of pure water? pH of pure water is 7. So how do the pH values of the distillate and of the solution left in the flask compare with the original solution? So you should realize that if I have sodium hydroxide solution and it is distilling off, that means I'm removing the water. That means the solution in the flask is becoming more concentrated, so its pH will be higher because that's a base. So the pH of the solution left in the flask would be higher than the original. But what about the pH of the distillate? The distillate we said is pure water. Pure water is 7, so that is lower than the distillate. So my answer is C. Okay, right? Okay, the next one. A solution of zinc sulfate can be made by adding an excess either of zinc carbonate or zinc hydroxide to dilute sulfuric acid. So he's trying to make zinc sulfate. Now, he's going to react what with the dilute sulfuric acid? He's saying either zinc carbonate or zinc hydroxide. Now, which method are we using? Both zinc carbonate and zinc hydroxide are insoluble. So I'm starting with something that is insoluble. So I'm starting with both of them solid. So he's actually going to need neutralization reaction in which both the reactants are solids. Right? Okay. The apparatus shown can be used to prepare aqueous copper sulfate. So what is he doing? He's trying to make copper sulfate. Now he can make copper sulfate from reaction of what with what? The solid X, if it is copper, we cannot use copper and iron 2 sulfate. We need a base and an acid. So we're going to use copper oxide and sulfuric acid. We said copper oxide with sulfuric acid will make up copper sulfate. Barium hydroxide is an alkali. It reacts with hydrochloric acid. What happens to the pH of a solution of hydrochloric acid as an excess of aqueous barium hydroxide is added? So remember, he's saying excess. So we're starting with hydrochloric acid. So we're starting with hydrochloric acid in the flask. Now, what is the pH of the hydrochloric acid? The hydrochloric acid has a pH of 1, 2, 3, maybe. Okay, so we're starting from 1 And then we're adding barium hydroxide. What would be the pH of barium hydroxide? Barium hydroxide is a strong base, so 12, 13, 14. So as I add the barium hydroxide to the hydrochloric acid, the pH will change from 1 to 2 to 3 until I add excess of barium hydroxide. That means that the solution will become 14. So the pH increases from 1 to 14. Okay, diagrams show 3 experiments using dilute sulfuric acid. 3 different powders are added. The mixtures are stirred. Which test tubes contain copper ions? Now, in order to contain copper ions, that means we must have a reaction in which the copper ions form. So, in test tube 1, he's reacting copper with sulfuric acid. You have to remember that copper, as a metal, does not react with acid. So, actually, in test tube 1, you're not going to have any reaction. But in test tube 2, you have copper hydroxide and sulfuric acid. That's a base with an acid. Yes, you're going to end up with a salt, copper sulfate actually. In the third test tube, you're reacting carbonate with sulfuric acid. So carbonate with acid will react. So you will have reactions. So you will have copper ions only in test tube 2 and 3. Okay, he's saying 2 indicators, bromophenol blue and Congo red, show the following colors in acidic solutions. Of course, when we talked about indicators, we never mentioned these 2 indicators, but then he's giving me the information that I need. He's telling me that bromophenol blue, in acid it's yellow, in alkali it is blue. Congo red, in acid it's violet, in alkali it is red. And he's saying a few drops of each indicator are added to separate samples of a solution of pH 2. So the first thing you ask yourself is pH 2, acid or base? Acid or alkali? It's acid. So if I put bromophenol blue into it, well, he's telling me that bromophenol blue in acid gives what color? Yellow. And Congo red in acid gives violet. So my answer must be D. Right? Okay. He's saying some reactions of the substance R are shown. He says R reacts with magnesium and with carbonate and with copper oxide. That means it reacts with metal, with carbonate, with base. What is the substance that will react with these things? Of course, it must be an acid. Dilute hydrochloric acid is added to a solid S. A flammable gas G is formed. The gas G is less dense than air. So what are S and G? So let's take a look at gas G. He's saying it's a flammable gas. So is it hydrogen or carbon dioxide? You should remember that hydrogen is the flammable gas. Okay. And then he's saying dilute hydrochloric acid is added to solid S. So he's adding acid to something to give hydrogen. Now we add acid to what to give hydrogen? We said we add acid to metals to give hydrogen. But will it react with copper? No, copper does not react with acid, so it has to be zinc, right? Okay. Ant stings hurt because of the methanoic acid produced by the ant. Which substance could most safely be used to neutralize the acid? Now, to neutralize the acid, I need a base. A base means the pH should be more than 7. But he's saying safely. Safely, that means that I shouldn't add something that is a strong base, because a strong base is corrosive. Do you know the meaning of corrosive? Corrosive means it will burn the skin, so it's not safe. So something with pH 14 is not safe, so I have to add something with pH 8. Okay, so hydrochloric acid is used to clean metals. The acid reacts with the oxide layer on the surface of the metal, forming a salt and water. Which word describes the metal oxide? We said if the acid reacts with it, then that thing must be a base, right? Which reaction will result in a decrease in pH? Okay, a decrease in pH, in order to lower the pH of something, you have to add acid or you have to add base. If you add acid, it will lower the pH. If you add base, base is very high, so it will increase the pH. So if I want to decrease the pH of something, I need to add acid. So which of these says I should add acid? So adding citric acid would decrease the pH. In an experiment, 0.1 gram samples of sodium oxide, magnesium oxide, phosphorus oxide, and sulfur dioxide are added to separate volumes of water. So for which oxide is the resulting mixture most alkaline? Remember that the oxide is alkaline if it is metal, if it's oxide of a metal. Now, something that is more metallic, more reactive as a metal, would be more alkaline. And we said if we look at the periodic table, where do I have the more reactive metals? We said the more reactive metals are in group 1, more than group 2, more than group 3, more neutralization. So something in group 1, when it forms an oxide, it will be more alkaline than something in group 2. Okay? Acids are compounds which donate protons. Which compound in this equation is behaving as an acid? Now you should remember, he says that acids are proton donors. So which of these gives protons? And I'm looking, if he says which one is the acid and which one is the base and things like that, you're looking at the reactants. So in ammonia plus water, from this reaction, which of them gave an H plus to another one? You realize that the NH3 changed into NH4. That means it received the H plus ions. And the water changed into OH minus. That means it is the water that lost an H plus, or it donated an H plus. So in this case, it is the water that is acting as an acid. Do we understand that? So usually we say water is neutral, but actually water has the ability of acting as an acid, and it also has the ability of acting as a base. So it is actually another example of amphoteric substance. Okay, the reactions of 4 different oxides, W, X, Y, and Z, are shown. Now he's saying W reacts with hydrochloric but not sodium hydroxide. Now if something reacts with acid, that means it is a base. So W must be a base. Where is W? W is a base. So my answer is probably D. Now X reacts with both acid and base, so that must be amphoteric. So X is the amphoteric one. That's correct. Now Y does not react with either, and we said the one that does not react with either is neutral, so Y is neutral. Z reacts with sodium hydroxide but not hydrochloric acid, so Z reacts with a base, so Z must be acid. So the answer is D. Can you see that? Now define the term acid. Remember we said what was the definition of the term acid? Proton donor. Sulfuric acid is a strong acid. Ethane dioic acid is a weak acid. Given solutions of both acids, how could you show that the sulfuric acid is strong acid and ethane dioic acid is a weak acid? Okay, to determine if something is strong or weak, we said we cannot use litmus because litmus just tells me if it's acid or base. So I need to use universal indicator. So what we do is insert universal indicator paper and compare the color obtained to the chart. Now, you have to tell me, how do I know if something is strong or weak? The strong will have lower pH, or you could say that the strong will give you a red color, while ethanoic acid, which is weak, should give a pH 4 to 6, or you can tell me it will give yellow or orange. Okay? Define the term base. Again, what is base? Proton acceptor. Given aqueous solutions of ammonia and sodium hydroxide, both having a concentration of this, how could you show that the ammonia is the weaker base? Again, you're going to use universal indicator paper. So what do I tell him? I tell him insert universal indicator paper and compare the color to the chart. Now, ammonia would have lower pH than sodium hydroxide to indicate that it is a weaker base. Okay, he's saying I have silicon dioxide and zirconium oxide are both macromolecules. They have similar physical properties, but silicon oxide is acidic and zirconium oxide is amphoteric. Now, name a reagent that reacts with both, the oxides of both. Now, I have something acidic and something amphoteric. So, if I add an acid, it will not react with silicon oxide. But if I add a base, it will react with the silicon oxide and with the amphoteric one that reacts with either. So actually what I'm supposed to write is a base. So just a base, the most common base that we have is sodium hydroxide. Name a reagent that reacts with only one of the oxides. So you want something that will not react with one of them. And you know that the amphoteric would react with both, so you want something that will not react with silicon oxide. If silicon oxide is acidic, then if I put an acid, it will react only with the amphoteric one, not with the acidic one. Okay? I am assuming, of course, that you have read these questions, tried them, and have an idea about them. Okay? What type of reagent is the phosphate ion? Okay, let's look at the equation. What has happened to the phosphate ion? The phosphate ion is the PO4 3-. It has changed into H2PO4, and that means that it has received H pluses. It has taken H pluses. So actually, in this case, it's acting as a base because it accepts protons. Okay? Now, we have a list of oxides, and he's saying which of the above oxides will react with hydrochloric but not sodium hydroxide. Okay, so I want something that reacts only with acid, so it has to be a base. Which of these is a base? We said a base is usually the oxide of what? Oxide of metals. So, lithium oxide, that's one. I cannot put aluminum oxide because aluminum oxide is not basic, it's amphoteric. Which one is the other basic one? Strontium oxide. So here you're supposed to write all of these. If you don't write both, you don't get the mark. Which of the above oxides will react with aqueous sodium hydroxide but not with hydrochloric acid? So I want something that will react with a base, so it must be acid. Which of these is acidic? We said acidic means oxide of a non-metal. So, which of these is acidic? Sulfur dioxide, and which one? And nitrogen dioxide. Okay. Which of the above oxides will react with both hydrochloric and sodium hydroxide? In order to react with both, it has to be amphoteric. So, which of these is amphoteric? We said oxides of aluminium, zinc, and lead are amphoteric. Which of the above oxides will not react with either of them? If it doesn't react with either of them, that means it is neutral. Which of these did we say is neutral? The carbon monoxide. Okay? Okay. So, let's complete these reactions. He's giving me an acid that I haven't seen before. So, this is called hexane sulfuric acid, and he's giving me the formula. Again, I'm going to remind you that these kinds of acids are what we call organic acids. And in the organic acids, the hydrogen that is being donated is the one at the end. So when I have C6H13SO3H, it is the H at the end that I'm going to remove and put something instead of it. So if I'm reacting magnesium with hexane sulfonic acid, remember that if this was, let's say, sulfuric, it would have given magnesium sulfate. This is hexane sulfonic. So it will give what? It will give magnesium hexane sulfonate. Plus what? This is a metal with acid. A metal with acid will give hydrogen gas. So whatever he gives you, it is something 8. Magnesium hexane sulfonate plus hydrogen. Okay. If I'm doing calcium oxide with hexane sulfonic acid, then I would have calcium hexane sulfonate plus what? Calcium oxide is a base, it's reacting with an acid, so it gives a salt plus water. Now, let's write this in symbol. Remember, if he starts an equation with words, you have to complete it with words. If he starts it with symbols, you have to complete it with symbols and balance. Okay, so he's starting with the hexane sulfonic acid plus sodium carbonate. First of all, we know that any acid plus carbonate should give something plus carbon dioxide plus water, right? Okay, so what would be that something? We said that the acid is an organic acid, so I'm going to remove the H at the end and put instead of it sodium. Okay, so this is what would be called sodium hexane sulfonate. Plus what? Plus carbon dioxide plus water. But then we need to balance, because the sodium before the arrow I have 2, so I have to put 2 after the arrow, and that means that I have 2 of all of this hexane sulfonic part. Okay? Okay, let's try this one. Lithium plus HI. What is HI? He gives me that HI is hydroiodic acid. Remember that iodine is a halogen, so this is just like HCl, HF. So if it were HCl, it was hydrochloric. HI, it's hydroiodic. So metal with acid. Metal with acid will give what? We said if we have lithium plus hydrogen iodide, this should give lithium iodide plus what? plus hydrogen. Remember, hydrogen is diatomic, it has to be 2. Then I need to balance. So, 1 lithium before the arrow, 1 lithium after the arrow. Now the hydrogens, 1 hydrogen before the arrow, 2 hydrogens after the arrow, so I need to put 2 here. But that means that now I have 2 iodine, so I need to put 2 iodine after that, and now I need 2 lithiums, so this is 2 lithiums. Can you see that? Okay, zinc carbonate plus hydroiodic acid. Again, carbonate plus acid will give my salt, which is zinc iodide. This is just like hydrochloric acid. If this were hydrochloric, it would be zinc chloride. Hydroiodic, zinc iodide. Plus what? This is carbonate plus acid, so it gives carbon dioxide and water. Okay, now I have magnesium oxide plus hydroiodic acid, so what should that give me again? Magnesium iodide. Again, the valency of magnesium is 2, so I have to put 2 under the iodine. Plus what? This is base plus acid, so this gives water. Now I need to balance. I have 2 iodines after the arrow, so I need to put 2 here in order to balance the iodine and actually to balance the hydrogens. Okay, good. Let's try this. Sodium hydroxide plus malonic acid. Again, we said if we have something plus an acid, it gives a salt, and the salt is written as sodium malonate. Okay, plus what? Well, let's see. Is this acid plus base, or is this metal plus acid? So this is acid plus base, gives salt plus water. Okay, next one, copper oxide plus sulfuric acid. You should realize this should give you what? Copper sulfate, and again, I'm going to remind you that the valency of copper is 2, valency of sulfate is 2, so you don't put 2 under any of them. Plus, what? This is acid with base, so this is plus water. Is it balanced, or does it need balancing? No, it's balanced. Okay, the next one, magnesium plus a certain acid, and we said we're going to remove the hydrogen at the end. But remember that this now has 2 hydrogens, and that is perfectly okay because the valency of magnesium is 2. So I removed the 2 hydrogens that are inside there. I put magnesium, and what is left? This is acid plus metal, so I'm left with hydrogen. Balanced or not balanced? No, it's balanced. Okay, potassium carbonate plus sulfuric acid. Again, carbonate plus acid will give a salt, potassium sulfate. Valency of sulfate is 2, so I have to put 2 under the potassium. And carbon dioxide and water. Balanced or not balanced? Can you see that it's balanced? Okay. Here the question says antimonoxide is a white powder which is insoluble in water. Describe how you would find out if it is a base, acid or amphoteric oxide. Okay? Okay, let's try this. Basic, acidic, or amphoteric oxide. If it's a base, it would react with acid. If it's an acid, it would react with base. If it's amphoteric, it reacts with both. So actually what we're going to do is we're going to bring 2 test tubes, put acid in one and base in the other, and see if it reacts, it will dissolve. So, if it reacts with acid, it will dissolve, and if it dissolves in the acid, then it is a base. If it dissolves in the base, then it's an acid. If it dissolves in both, then it's amphoteric. So, describe in detail, one by one. Put 10 centimeter cubed, for example, of aqueous sodium hydroxide into test tube, 10 centimeter cubed of dilute HCl into another test tube. Add equal amounts of the solid that we're testing. If it dissolves only in sodium hydroxide, it's acidic. If it dissolves only in HCl, it is basic. If it dissolves in both, it is amphoteric. Okay? Explain the terms strong acid and weak acid. When he says explain the terms, he wants the definition. Remember, strong acid ionizes completely to give lots of H plus ions. Weak acid ionizes partially to give a small amount of H plus ions. Okay. It's possible to determine whether a substance is acidic, neutral, basic, or amphoteric using an acid and an alkali. So complete the table of possible results. If the oxide is predicted to react, write R. If it is predicted not to react, write NR. So if something is acidic, an oxide is acidic, that means it will react with what? Acid reacts only with base. So there is no reaction with the acid, but there is reaction with the base. Now if something is neutral, we said if it's neutral, it will not react with either acid or base. Now if it is basic, basic will react with acid but not with a base. Amphoteric will react with both. Right? Beryllium hydroxide, a white solid, is an amphoteric hydroxide. Name another metal which has an amphoteric hydroxide. Remember, which ones do we have in the syllabus that are amphoteric? Aluminium, zinc, or lead. So you can write any one of them. Aluminium, he says, name the metal that has an amphoteric hydroxide. So either aluminium or zinc or lead. Okay, so just what you would observe when an excess of sodium hydroxide is added gradually to beryllium sulfate. Now, if I'm looking at beryllium sulfate reacts with sodium hydroxide to give what? To give sodium sulfate plus beryllium hydroxide. Now, that is a white solid as it tells me on top. So that will form a precipitate at the beginning, but then it is amphoteric. That means that this beryllium hydroxide will react if you add more and more sodium hydroxide. So it will start to dissolve again. So what happens is when you're adding sodium hydroxide to the beryllium sulfate, it forms beryllium hydroxide. That's a white precipitate. But then you're adding more and more of sodium hydroxide. So this sodium hydroxide will react with the white precipitate that is formed because it's amphoteric. And it will dissolve and form a colorless solution. Okay. E numbers identify chemicals which are added to foods. E210 is benzoic acid. How could you show that a solution of benzoic acid is a weak acid? Again, how do we show if something is a weak acid or weak base, strong acid or strong base? Insert universal indicator paper, compare the color to the chart. If it is a weak acid, what should I get? You can either say that I will get pH 4 to 6, or you can tell me that the indicator paper will turn orange or yellow. E211 is sodium benzoate. Name a suitable substance that would react with a solution of benzoic acid to form sodium benzoate. Okay, I want something to react with acid. Now, what reacts with acid? It's either a metal or a base or a carbonate. So actually, you can either say sodium hydroxide, that's the base, or I could just say sodium if I want, or I could say sodium carbonate. Any of them would react with the acid. Okay, this is an experiment. Cleanup is a colorless liquid used to clean work surfaces and glass windows. It contains ammonia solution, which is a weak alkali. Plan an experiment to determine the concentration of ammonia in cleanup. So remember that here, he's not asking you to prepare a salt. You just have a solution of a base and you want to know what is the concentration. It's just like the one where we said we wanted to know which one is more concentrated than the other. So you're just going to explain titration, but you're not going to go on and prepare the salt. So what we're doing is put 25 centimeter cubed of the ammonia solution into a flask using a pipette. Add 3 drops phenolphthalein. The solution turns pink. Add dilute nitric acid from a burette until the pink color disappears. Note the volume of acid used and then calculate the concentration. So all you're doing is you're doing titration in order to know how much acid I need to react with this specific amount of ammonia. Then I can go on and calculate the concentration. Okay. The diagram shows the apparatus used by a student to find concentration of hydrochloric acid. Sodium hydroxide was added to hydrochloric acid until the solution was neutral. Now the first thing is complete the boxes. What are these apparatus? Again, the one with graduations and tap, that is burette. The other one that I used to put the solution into the flask is the pipette. Please note the spelling. You're expected to write things with the correct spelling. And of course, this is a flask, or you could be specific and say conical flask. How could the student tell when the solution was neutral? How do we know if the solution becomes neutral when I'm doing titration? Well, when we do titration, all these solutions are colorless, and we said in order to know whether the solution has become neutral or not, I should do what? I should add some sort of indicator at the beginning, and then the color will change. If we put methyl orange, then at the beginning it will be red because I have acid in the flask, and then it should change to orange. That is the indication that the solution has become neutral. Okay. The next question, strontium chloride 6 water is made from insoluble compound. Remember, when we say something 6 water, that means I am preparing a hydrated salt that contains water in the crystals as they form. Okay, so he's trying to prepare strontium chloride 6 water, and he says this is the method that we're using. He says add excess strontium carbonate to hot hydrochloric acid. So how would you know when excess solid has been added? When we do this, first of all, which method is he using? Is he using titration or neutralization or precipitation? Well, if we're adding excess solid to the acid at the beginning and then we're going to filter, this is the one that we called neutralization. So when I added the excess solid at the beginning, how do I know that I have finished or that the solid has been excess? If excess solid remains in the beaker, right? Why is it necessary to filter the mixture in step 2? Of course, why are you filtering in step 2? To remove what? To remove the excess solid that we added. We don't want it. Now, what do I want? I want the filtrate. Partially evaporate the filtrate to allow to cool. And he's saying, why are we partially evaporating the filtrate rather than evaporating to dryness? And we said, if I'm trying to make hydrated crystals, if I evaporate to dryness, then I will lose the water of crystallization. So I need to partially evaporate or heat to point of crystallization in order to avoid loss of water of crystallization. Okay? Okay, 3 ways of making salts are titration, neutralization, precipitation. Now you need to write the reagents that are needed in order to prepare certain salts. The word reagent, first of all, is the substance that is reacting. So if I'm reacting acid with base, these are my reagents. So the first salt that he's trying to make is sodium nitrate. Now the question is, he's going to make sodium nitrate from what and what? Of course, if I'm doing titration, that means I'm reacting it from, preparing it from acid and base. Now, which acid am I using and which base am I using? Well, to prepare sodium nitrate, I need sodium something and something that has nitrate. So sodium hydroxide would be my base, and the acid that contains nitrate is nitric acid. Okay, the next salt, copper nitrate, he's trying to make it by neutralization. That means he's going to have a beaker with nitric acid. What is he going to add to the nitric acid in order to make copper nitrate? He wants copper something. So you can either say copper 2 oxide or you could say copper 2 carbonate. Either of them will give the correct salt. Okay, precipitation means I'm starting with 2 things that are soluble in order to form something that is insoluble. So silver chloride is insoluble, it will form a white precipitate. So I need silver something that is soluble and something chloride that is soluble. And we said silver what may be soluble? We said all nitrates are soluble, so the safest thing would be to say silver nitrate. Plus something chloride, so I could say sodium chloride because we said all sodium salts are soluble. Now, if he's trying to react zinc carbonate with sulfuric acid, what is he trying to make? He's trying to make zinc sulfate. Right? Okay. Soluble salts can be made using a base and an acid. Complete this method of preparing dry crystals of the soluble salt, cobalt 2 chloride, 6 water, from the insoluble base cobalt carbonate. Now, the first thing I need to ask myself, what am I trying to prepare and what am I going to use to prepare it? I'm trying to make copper 2 chloride. So he's reacting copper 2 carbonate with acid. Now, you should know that copper 2 carbonate is soluble or insoluble. Well, he actually tells you that it is insoluble. So I'm starting with an insoluble salt, and that means I'm trying to explain which method. Neutralization. If I'm starting with something insoluble, I'm trying to explain neutralization. So in neutralization method, the first thing we do is add excess cobalt 2 carbonate to hot dilute hydrochloric acid. Then what? We have excess solid in the beaker, so the next step would be to filter the mixture through filter paper and funnel. And do I want the residue or the filtrate? No, I want the filtrate, because the residue is the excess solid that I don't want. So I'm going to take the filtrate, heat the filtrate to point of crystallization, cool, filter the crystals, and then dry the crystals between filter papers. Okay. Soluble salts can be made by neutralization of an acid by a base. Insoluble salts can be made by precipitation. The following is a brief description of the preparation of a soluble salt. Nickel carbonate is added in small amounts to hot hydrochloric acid. So he's adding nickel carbonate, hydrochloric acid, and he's trying to make nickel chloride. Why is it necessary to use excess carbonate? We said in this method, I keep adding the solid carbonate until it is excess, until excess solid remains in the beaker. Why do I need to do that? To make sure that all the acid reacts. Explain why it's necessary to filter. We said we're filtering to remove what? To remove the excess solid that I add. Why partially evaporate rather than evaporate to dryness? We said to avoid loss of water of crystallization. He's trying to make nickel chloride 6 water. So this is something that is hydrated with water of crystallization. I don't want the water to evaporate. What additional steps are needed to obtain dry crystals? Okay, where did he stop? He said the filtrate is partially evaporated and then allowed to cool until the crystals form. What do I do next to the crystals? I filter through filter paper and funnel, dry the crystals between filter papers. I could also wash before I dry. Okay, potassium chloride can be made from hydrochloric acid and potassium carbonate. Why must a different experimental method be used for this preparation? Now, the other method, he was making what? He was describing neutralization method. But if I'm trying to start with potassium carbonate, what is the difference? The difference now is potassium carbonate is a soluble salt. So I don't need to do neutralization. I should actually be describing titration, right? If everything is soluble. So the difference here is that potassium carbonate is soluble in water, and that means I need to describe titration. So give it the description of the different methods. So you're describing titration. How do we describe titration? With 25 centimeter cubed of HCl in a flask, add 3 drops methyl orange, add potassium carbonate solution from a burette until the solution turns from red to orange. Note the amount of carbonate used. Repeat without indicator. Heat to point of crystallization. Cool, filter the crystals. Okay. A student prepared some crystals of sodium nitrate. The following extract was taken from her notes. What piece of apparatus should be used to measure the aqueous sodium hydroxide? She said she put into the conical flask 25 centimeter cubed of sodium hydroxide. Using what? Using pipette. Now, she's titrating sodium hydroxide with nitric acid. What is the suitable indicator that we could use? We either could use phenolphthalein or methyl orange. These are the 2 indicators that we use for titration. So which one do we want to choose? Let's say choose methyl orange. Okay, I'm putting it on what in the flask? On a base in the flask. Methyl orange on the base is yellow. So it will change from yellow to orange. Which solution was less concentrated? Well, how do I know that? I had 25 centimeter cubed of the sodium hydroxide. And when she added the acid, she needed 29 of the acid. So if I need 29 of the acid in order to neutralize 25 of the base, which of these is less concentrated? You should realize that if something is less concentrated, you need to use more of it. So the one that I used more of it is nitric acid, because more of it was needed to neutralize less amount of sodium hydroxide. Okay. How could the student obtain pure crystals of sodium nitrate using this method? So she already did titration. What should she do next? We said after you do titration, repeat using the same amount of sodium hydroxide and the same amount of acid, but no indicator. Heat to point of crystallization, cool, filter the crystals. Right? Okay, the other question. Zinc blend is an ore of zinc containing zinc sulfide. A student attempted to obtain a sample of zinc metal from this ore. The diagram shows the process. So she has a lump of zinc blend heated to form zinc oxide. Zinc oxide was crushed. dilute acid was added. The mixture was added to the mixture was separated to give a solution of zinc sulfate. Okay, the name of that thing is a dropper. Okay, did you realize it was a dropper? Okay, explain why the student should have carried out stage 2 before stage 1. Which one is stage 2? Stage 2 is the crushing. Well, I need to crush the solid before I start doing any reaction. So actually I should have crushed the zinc blend first before continuing to react. So this is to increase the surface area for faster reaction. We'll talk about that more when we talk about rates of reaction. Identify the dilute acid used in stage 3. Well, what is she trying to make? Let's go back. She's trying to make zinc sulfate. Then my acid should be sulfuric acid. Name the process used in stage 4. I'm sorry, I'll go back and see what is stage 4. Stage 4 was the mixture was separated to give a solution of zinc sulfate. Well, which method is he doing there? He's doing filtration. So just how the students could have obtained a sample of zinc from the zinc sulfate solution. Okay, he has a zinc sulfate solution and he wants a sample of zinc. This is actually something that we haven't done yet, and I will just mention it, that if you add a more reactive metal to a solution, it will displace the zinc. So if I add magnesium to zinc sulfate, remember when we're doing reactions, what plus zinc sulfate will give you zinc? So something like magnesium plus zinc sulfate will give zinc, right? Plus magnesium sulfate solution. Okay, the following instructions were used to prepare magnesium sulfate crystals. So he's trying to make magnesium sulfate 7 water. That means he wants hydrated salt with water of crystallization. So he says measure 50 centimeter cubed of dilute sulfuric acid into a beaker and warm the solution. And then the first question says, why is the sulfuric acid warmed? Why do you think he's warming the solution? When we heat any solution that we're reacting, this is to speed up the reaction, to make the reaction faster. How would you know when excess magnesium oxide was present? Well, when we add this, first of all, he's doing neutralization, right? So when we add excess solid, how do I know that it is excess when excess solid remains in the beaker? What method is used in step 3? Well, in step 3, he's saying separate the excess from the solution. We separate the excess solid from the solution by filtration. Why must care be taken when drying the crystals? Again, to avoid loss of water of crystallization. Right? Okay, explain how the method would differ if magnesium carbonate were used instead of magnesium oxide. Now, in this question, the magnesium carbonate and the magnesium oxide are both solids that are insoluble in water. So when I'm doing magnesium carbonate, I would still be using the same method, which is neutralization. But it will differ only in the fact that with magnesium oxide, he had to heat the sulfuric acid to speed up the reaction. But with magnesium carbonate, acid should not be heated or warmed, since carbonates react quickly with acid. As soon as I add acid to carbonate to react, I don't need to warm up the acid. Okay, this is a question from the end of paper 6. Calcium carbonate is found in limestone and in marble. All carbonates react with acids to form chlorides. Calcium carbonate is insoluble in water. Calcium chloride is water soluble. Most impurities in limestone and marble are insoluble. So I have two samples, limestone and marble. Both of them are calcium carbonate plus some impurity. And the question is, how much impurity in each of them? Now, the calcium carbonate itself is insoluble, but if I add hydrochloric acid, it will dissolve. He's saying calcium chloride is water soluble. So if I add hydrochloric acid with calcium carbonate, it will dissolve. So the basic method that I would be thinking of is I should add acid to both limestone and marble. The calcium carbonate will dissolve. Any impurities will not dissolve. So I will filter, weigh, and see which one has more impurities. So this is basically what we're doing, but you need to explain it in detail one by one. So we weigh a specific amount of the first one, limestone for example, because we need to compare, so we need to use same masses of both. So weigh 10 grams of limestone using a balance, put into a beaker, add excess dilute hydrochloric acid, stir using a glass rod until what? How do I know if the reaction has finished? Until no more bubbles of gas are given off. because this is carbonate with acid. It should give out carbon dioxide gas. Filter through filter paper and funnel. Wash the residue with a few drops of distilled water. Dry between filter papers. Weigh the residue. So now I know how much impurities in the limestone. I do the same thing with 10 grams of marble, and the one that has more residue has more impurities. You understand that? Easy, straightforward. Okay, that's the end of the chapter. Please go back, study the chapter, and do the chapterized questions. Okay.